Alright, hello everyone, this is Mr. Crozier. I want to help you with today's lesson. We have one thing to do here, and that's going to be to convert complex numbers into trig form. It's just like in middle school you took fractions and turned them into decimals. Two ways to represent the exact same thing. That's what we're going to do. We've been working with complex numbers, and they look like this, a plus bi. Now we're going to work with trig numbers, and they look like this. And it's the exact same number. I'm going to show you how they match up, but we need to take something that looks like this and turn it into this form, where r is the modulus, which is the same word as magnitude, same meaning, and absolute value, and we'll show you that. And theta is the argument, or the direction. And what you're going to see is these are very, very similar to vectors. If you were good with vectors, it'll be the same stuff. So here we go. Example A. This complex number 3 plus 4i. Well, first off, we can graph it. We can graph this number. It's 3 on the real axis, so 1, 2, 3, and 4i on the imaginary axis. And this is the imaginary axis. You've probably never done this before, but you can graph numbers with real parts and imaginary parts, just like an x-y axis, but now it's real imaginary. And this is 1i, 2i, 3i, 4i. Just like counting 1, 2, 3, but I'm counting by i's. And if I plot this point over 3 up 4, that's the point, and that's where that point is. And we could draw a vector, and that was the last chapter, but I'm not going to draw a vector. I'm just going to draw a dashed line there. So we have that point right there, and it's exactly like you did in middle school when you plotted that point over 3 up 4. But now what we're going to do is talk about a few things of this. First off, let's find we want to take this and do it in this form. So we need the radius, if you want to think of it that way, or the modulus, absolute value, and just remember what we did last time. The square root of 3 squared plus 4 squared is 5, because it's a 3, 4, 5 triangle, and that makes sense, and that's the absolute value. The word is absolute value. It doesn't really mean the same thing it does in algebra. In algebra, we did the absolute value of -7 is 7. But when you have imaginary numbers, it means something different. It means just find the magnitude. Alright, so what is theta? Well, it's the same thing we did before. Inverse tangent of opposite b over a. So let me grab my calculator, and you can use a calculator now on this chapter, this unit, or sorry, this lesson. 4 divided by 3 is 53.1 degrees. And do we have to add 180 or 360? No, we're in quadrant 1. So this angle right here is 53 degrees. Alright, so now we have all the parts to turn this into this. Let me write down our complex number, 3 plus 4i. That's the complex form, and we're going to change it into the trig form. Complex trig form. Well, we start with the r, 5, and we do cosine 53.1 degrees plus I sine of 53.1 degrees. Now that may look more complicated, and it definitely is longer, but some math problems we're going to do in the future, it's a lot easier to work with this number. Now let me just check this. 5 cosine 53.1 is 3, did a little rounding, and 5 sine 53.1 is 4 with a little bit of rounding. And it should match up to what we did with vectors, right? What did we do with vectors? We wrote them out all the time, and we put cosine, sine. We're doing the exact same thing right here. Alright, so that's what our assignment is today. Take complex numbers, write them in trig form. That's all you have to do, and graph them. Alright, let's do a couple more examples. Example B, here's our complex number. Let's graph it. Over to 2 on the real, 1, 2, and down to this. And if you do the decimal there, that's about 1.73. So there's 1i, negative. There's negative 2i. So over to 2, 1.7. Well, right there's the point. Could be a vector, but we're just going to call it a point. And now let's find the r value. The r value is the absolute value of that. Well, how do you do absolute value with an imaginary number? Not like in algebra. you do 2 squared plus root 3 squared, which is the square root of 7. That's what we mean by absolute value. It's different than an algebra class. All right. What is the inverse tangent? Inverse tangent of b, which is negative root 3 over 2. All right, let's see here. Inverse tangent negative root 3 divided by 2. 40 degrees, what does that mean? It's a 40 degrees drop from here, so I'm going to add 360 to it, and 319.1. 319.1 degrees. All right, I have my 2 parts necessary to change it. So here we go, ready? Complex number here, trig form, r, root 7, cosine of 319.1 plus I, sine of what? It's the same exact angle. And there you go. Trig form, complex form. It's kind of backwards, isn't it? This looks like the complex form over here. But let's see, square root of 7, cosine 319.1, checks out to 2, and just go, whoops, change my cosine to sine, and negative 1.73. All right, let's do one last example. Here's my imaginary number, negative 3i, let's put a 0 there. 0 on the real, and negative 1 to negative 3i down here. There's my point. Magnitude. Well, magnitude is the absolute value of that. And how do I do that? Well, I take the square root of it squared. Sorry, I square it. The square root of root 3 squared is back to just 3. Oh, sorry, I don't know why I put the root there. Got ahead of myself. Let me do that one again. It is negative 3i is simply negative 3 squared square rooted is just 3. So in this case, you do see it. The absolute value just gets rid of that here. But when you have the complex form, you have to go through all the work with the Pythagorean theorem. I got ahead of myself and put the square root there, but it's just 3. And you can see the magnitude is 3, right? If I draw this vector, it's 1, 2, 3. Now what is theta? Theta is inverse tangent of b, negative 3 over 0. Well, it's definitely going to be undefined, but that doesn't mean the angle's undefined. Where is this going? Well, I think we had this on the quiz a little bit ago. It's going to 270. All right, so let's take this complex number, here it is, and turn it into the trig form. The trig form would be 3. And what do we have here? Cosine 270 plus I sine 270, and done. And always check it. Ready? 3 cosine of 270. Well, that's 0. Because it should be 0. Alright, 3 sine of 270. Well, that's negative 3. Negative 3. All we're doing on today's assignment is taking these complex forms right here, complex numbers, and putting them into a trigonometric form, because in the next lessons we're going to do some work, and it's going to be actually nicer to have it in this form than this form over here. So that's all you have to do.